Cloud Manager Image 13 integrates with Oracle Data Science Services to take advantage of machine learning techniques. This enables Cloud Manager to learn from past usage and automatically respond to user surges managing compute resources, so that your users experience smooth, reliable performance. We'll look at the steps to set up and use autoscaling. An administrator sets up and configures the data science resources integrated with Cloud Manager. Enable monitoring on the targeted managed instances. This starts collecting PeopleTools Health Center system performance data and indexes that information in an Elasticsearch instance. Load the system with the typical load expected on a production system. You need to train the system with a minimum load of typical business transactions for at least 3 or 4 weeks in order to collect enough samples for prediction. Cloud Manager runs a weekly job that collects performance data for the instance and pushes the performance data to the object storage bucket. Another weekly job pulls this performance data, trains the model, and publishes the machine learning model in data science. Steps 3, 4, and 5 need to run for at least 3 weeks with enough sample load in order for the predictions to be accurate. Once the model is trained with this data, define a scaling policy using Policy Manager. When you select Autoscale in the Policy Action parameters, the system adds additional nodes when it detects anomalies. The system can generate 2 types of anomalies. A positive anomaly occurs when there's a surge of user requests above normal, indicating a scale-up event. A negative anomaly occurs when there is a decrease in system use, indicating a scaling down. Once configured, Cloud Manager collects performance data every 30 seconds and sends samples every 5 minutes to the Data Science Prediction API. When the system detects a positive anomaly, additional nodes are added to keep up with resource needs. Adding a new node typically takes 15 to 20 minutes. After a scale-up event is triggered, the system, by default, waits for a 4-hour lockdown period before bringing the system back to the base configuration by removing nodes. The system needs to detect a negative anomaly during the lockdown period in order for the system to remove the added nodes. This completes the description of the autoscaling using machine learning feature. Apply OCI tags to resources in Cloud Manager, including templates and provisioned environments, to identify and organize your environments. You can use the tags to help you find and track your environments in OCI. You can also specify tags as criteria when setting up policies for governance, as shown in the following segment. Before applying tags to Cloud Manager resources, administrators set up tag namespaces and add defined tags to them. Defined tags offer superior features and control, such as the ability to assign a list of values or a variable, as well as a string. End users can select from the defined tags when creating Cloud Manager resources. In the Oracle Cloud Infrastructure Console, select Governance and Administration, Governance, and Tag Namespace. Namespaces are essentially containers for defined tags. Click Create Namespace Definition. Select a compartment, enter PSFT FSCM for the namespace, and click Create Namespace Definition. Open the namespace and click Create Tag Key Definition. For the environment type tag, specify a list of values including demo, production, test, and training. Create the department tag in the same way with values procurement and finance. For the environment name defined tag, select static value, which allows the user to enter a string. In Cloud Manager, go to Settings, Infrastructure Settings. Click Refresh OCI Metadata to bring in the tagging information. Click the Environment Template tile and then select the FSCM Tags template. Edit the top-level attributes for the topology. Under the attributes for the template, select namespace PSFT FSCM, tag key name environment type, and value production. Add a second tag, environment name, and provide the variable name in brackets starting with a $, Cloud Manager environment name. When you use this template to provision an environment, this variable is resolved to the actual environment name. By default, these tags apply to all nodes and environments created from this template. You can override the default by adding tags to the attributes for the individual database tier or middle tier nodes. To change the tags on an existing environment, click View Details and select the Manage Attributes tab. Click Refresh. Now you can edit tags for the environment. This concludes the OCI Tagging Support enhancement demonstration. Policy governance enhancements include adding policies to a group using tags, adding policy groups to a template or environment, scheduling event-based policies, creating policies with multiple actions. Using OCI tags, you can associate multiple environments to a single policy. This allows you to define one policy for multiple environments without specifying environment names. On the Environments Details page, select Manage Attributes. When you select Refresh, the tagging section is displayed for each node. We will add a new tag for environment type to the Full Tier node. The tag namespace is Environment Type, the tag key is Type, and we'll set the tag value to Production. Click Update to save the changes. The same tag was applied to the FSCM demo environment. On the Policy Editor page, we'll associate this tag with the Stop Environments policy. In the Policy Conditions section, associate this policy with a tag rather than an environment. Use the property name tag. The operator is matches. The property value is based on the tag namespace. Then you can select the tag key value pair. The tag value is production. Save the changes. Schedule the policy and save. The Stop the Environments policy is now active and scheduled. Use the Policy Monitor to verify that the policy triggers at the scheduled time. Click the status icon for Stop Environments. We see that the policy was applied to both environments, since both of these environments have the same tag as set in the policy definition. Click the Details button to view the execution status. Policies can also be associated with a policy group, such as demo policies, production policies, and test policies. You can now associate the policy group with a template or add the policy group to an existing environment. To add the policy group to a template, select the Environment Template tile. Select the template and navigate to the Security and Policies page. The section to associate policies with templates now supports policy groups. You can now add individual policies or policy groups. We'll add a policy group. You can then select the policy group. Submit the template. When you use this template to provision an environment, the system applies this policy group to the environment. For existing environments, the policy page now supports policy groups as well as policies. We'll add the policy group demo policies and save. Use the Go to Policy Editor page link to view the policies. Expand the Demo Policies section to view the policies. The FSCM demo environment has been added to each policy in this section. Click the View Edit icon for each policy to see the added environment. For event-driven policies, click the Parameters button to see the environments. Prior to Cloud Manager 13, policy actions, such as applying PRPs, execute when an event triggers the policy. Now, customers can schedule an event-based policy action on an ad hoc or recurring schedule. This allows users to keep their managed environments untouched while they are in use and apply the updates during weekends or off times. To schedule a policy action, click the Governance tile. An event-based policy exists for Apply CPU patches. Select to edit that policy. The Policy Actions section now includes the ability to schedule the event. You can schedule the event on an ad hoc or recurring basis. There is also a Reset Schedule button if you need to reset the schedule. We'll schedule the event as a recurrence to run on Sunday. Save the schedule. Save the policy. Select Yes to regenerate the policy. Now, the Apply CPU Patches event runs on Sunday rather than being triggered by the download event. You can now set up multiple actions in a policy. we'll add a new policy to stop and start environments. In the Policy Editor, select Add Policy. Enter a name, description, and security role. The policy object is Environment, and we'll schedule this policy. In the Policy Conditions section, select Property Name, Name. The operator is in. Property values now have a lookup. Click the Lookup button on the Set Property Values page to select the environment name. We'll select FSCM Demo, then save. In the Policy Actions section, select the actions in the order in which they'll be performed. First, we'll select Stop, add a row, and select Start. Select the Schedule button to schedule this policy. We'll use Ad Hoc and enter a date and time, then save. Save the policy. The policy is now scheduled to run. After the policy executes, you can check the execution status using the Policy Monitor. Click the Status button for Multi-Action. The status is complete. Click the Details button to view the status details, such as start times. This page also provides a link to the logs. This concludes the description of the Policy Governance Enhancements feature. You can now add middle-tier components, such as web server domains and Kibana domains from your Cloud Manager environments to OCI load balancers. The Oracle Cloud Infrastructure Load Balancing Service provides automated traffic distribution from one entry point to multiple servers reachable from your Virtual Cloud Network, VCN. When you set up the load balancer, you define a backend set, which is a logical entity that includes a list of backend servers, a load balancing policy, such as weighted round-robin, a health check policy, and other options. First, set up the load balancer in OCI. Click Set up a load balancer. Enter a name and accept the options to create a public load balancer and assign a public IP address. Select the VCN and subnet. The VCN subnets must have security rules that allow the load balancer, listener, and backend servers to communicate. Click Next. For the load balancing policy, choose the method that the load balancer uses to distribute traffic, such as weighted round-robin. Don't select the backend servers at this point. We'll do that in Cloud Manager. Specify HTTP for the health check policy, which will test the availability of the backend servers. Enter 0 for the port and accept the other values. After setup, you can view the results of the health check on the Load Balancer Details page in OCI. Select the Show Advanced Setting link and change the backend set name to PIA Backend Set. Select the Session Persistence tab and the Enable Application Cookie Persistence option. Enter a cookie name. When you configure the load balancer for your environment, the configuration process uses this cookie name to update the PIA domain configuration. Click Next. To configure the listener, enter a name, HTTP as the type of traffic, and 8000 as the port. On the logging page, accept the defaults and submit. We also create a second public backend set for Kibana. In Cloud Manager, go to the Environment Details page. This environment includes 3 web servers. Select the Load Balancer Settings page. Enter the fully qualified domain name for the backend sets. The PIA FQDN is the fully qualified domain name that is resolved for the PIA backend sets. We'll use this URL to access the load balancer. Enter a descriptive name for the first part of the FQDN. The last portion of the FQDN must match the authentication domain, which is included with the web server settings when creating a template. To configure the backend set for the PIA nodes, select the compartment where you created the load balancer and the public load balancer. Choose the PIA backend set and PIA. Select the web server domains for the backends. Select HTTP Listener and use this listener for PIA, Integration Broker, and Report Node. We also configure the Kibana backend set. Click Update. The environment status shows as Configuring Load Balancer. The Environment Details page shows the Load Balancer URL, which we can use to access the environment. The Integration Broker Gateways page references the load balancer URL. This concludes the Configuring and Deploying Load Balancing as a Service demonstration. For existing environments managed by Cloud Manager, you can now apply critical patch updates to the infrastructure components such as Java, Tuxedo, WebLogic, and Oracle Database Client. A new page, Infra CPU Patches, is available from Environment Details, which shows the currently applied third-party component version details. If a valid infrastructure deployment package, or IDPK, is available, a message, Latest CPU Available, is displayed. The IDPK third-party component version information lists the available updates. Use the Apply button to apply the listed updates. This concludes the Performing Critical Patch Updates for Existing Environments description. Autonomous Database on Shared Infrastructure, ADBS, is now available for use with Cloud Manager, enabling the lowest cost entry point for ADB. Minimum PeopleTools requirements for this feature are 85901, 85809, 85720. Also note that in Cloud Manager 13, ATP Dedicated has been renamed to ADB Dedicated. Use the Import Environment option to import the ADBS environment from OCI. You'll be prompted for Autonomous Database credentials. Credentials include the DB Wallet password, which is used to download the ADB Wallet. DB Wallet functionality has also been added to ADB Dedicated. The ADB Wallet has an expiration of 2 years. Therefore, a new policy has been added to refresh all the ADB-based environment wallets, both shared and dedicated, in all the tiers, within every 18 months. This policy is automatically added to ADB environments. Use the Go to Policy Editor link to view the policy. Notice that the ADBS database was added to the policy. Click the Parameters button to change the expiry day count if desired. Use Manage Node on the imported environment to add the middle tier node. Please review Tech Update 2765965.1 on My Oracle Support for additional information. This completes the description of the Extending Autonomous Database Support for Shared Infrastructure feature. Host and domain names are now customizable. The General Settings section for each node of the topology in the template has a new hostname field. This example shows the full-tier node with the default hostname. You can change this hostname. The Domain Settings section for each tier includes a domain name field. You can set a custom domain name for web server, app server, and process scheduler. When you provision an environment, you can customize the hostname or domain names. You can also customize the hostname and domain names when you shift an environment. This completes the description of the Enabling Custom Host and Domain Names feature. This image supports Oracle Linux 8 for provisioned environments. To take advantage of Linux 8 features, create a VM with an Oracle Linux 8 image, apply the necessary YUM updates, and create a custom image. Add the OCID for the custom image to the Cloud Manager Infrastructure Setting page. Oracle 21c database software is available for your managed environments. When you configure the database system options during environment template creation, choose Oracle 21c database software for provisioned environments. This completes the description of the support for Oracle 21c and Linux 8 feature. We've only shown you the highlights of this Cloud Manager update. For more information and other enhancements, see the CFO tool, the image overview on My Oracle Support, and go to the PeopleSoft Information Portal for updates.